Okay, so here's part two. Let me put a little note up here. Oh, get rid of that. On the energy lecture. Last one we were talking about the history of energy and energy, a little bit of energy usage, but then more importantly, areas of our lives that use energy and industry being industrial energy consumption being the largest, and then we talk about energy consumption in transportation sector, residential, and then commercial in that order. So let's go back to this just to reinforce. I'll get purple color. So number one, number two, number three, and number four. And again, these things change, but not dramatically. And again, so as an environmental scientist, if we're going to try to make a change to policy, we have to figure out how will it impact these different areas. Do you do a policy directed at residential and not worry about industry or transportation, or do you focus on one versus the other, or do you just try to work on all of them? So challenges, but interesting things to work on. So, okay, so now let's talk about where does our energy come from? That's an important thing to know because then we can understand it better and we'll look at the pros and the cons. So, all right, so coal. Coal is still being used. In some countries, it's one of the more prevalent forms of energy. Coal originated from fossilized plant material that gets compacted over millions, literally hundreds of millions of years, compacted down and compressed and compressed and compressed into solid material. It requires an environment that has little or no oxygen, so an anoxygenic or abiotic type of environment. So during the Carboniferous period of the Earth's history, going back 286 to roughly 360 million years ago, we had these swamps all over different parts of the Earth. North America, Europe, Asia, etc., had these swamps. And as the vegetation died, it would fall into the water, sink down, get covered in sediment, compress down and compress down and continue to compress down over hundreds of millions of years and compressed that carbon-based plant material into what we call coal today. So the challenge is coal has or contains sulfur, mercury, and cadmium. Okay, those are three of the elements we're concerned about. Sulfur comes from the swamp environment. When it was compressed in those swamps, sulfur often is present in swamps. The mercury and the cadmium, those two were uptaken or absorbed by the plants when the plants were alive and incorporated into the body of the plant. So then that gets condensed down into the coal itself. So when we take coal and burn it, we're releasing all of that. We're also releasing large amounts of carbon, generally in the form of carbon dioxide, because you're burning a carbon-based fuel source, like burning a piece of wood. It's a carbon-based fuel source. So coal is literally fossilized wood that has compressed over long periods of time. So when we burn coal, we unfortunately release a lot of pollution into the environment. So sulfur dioxide, nitrogen dioxide, particulate, coal ash. I can tell you, growing up near a coal-fired power plant, it was not fun. Houses would get covered in ash. The siding would start to corrode. Everything would, at different times of year, would have this kind of little dusty pit dirt nastiness on it from the coal ash. It releases hydrocarbons, it releases carbon monoxide, and here's our infamous mercury. Mercury, one of those most toxic metals in the environment that bioaccumulates. So remember, bioaccumulate, accumulate into environments as it goes up the food chain, it magnifies. So your top level carnivores, mercury, swordfish, tuna, polar bears, etc. Because of this. Where does mercury come from? A lot of it's released through the combustion of coal and coal-fired power plants. Now, there is some talk, some ideas about, hey, when we burn coal, remember, carbon's coming off of it, carbon monoxide or carbon dioxide. Can we sequester this? Can we grab that carbon and shove it back down into the earth? Ooh, interesting concept. Can we take it, push it down into the earth, and store it? Sounds like it. Okay, it's not going into the atmosphere. It's basically taking the carbon. We took the carbon out when we took the coal out. Now we're putting the carbon back in, and we got the energy. Sounds great. But the problem is, it's not efficient, and it's not an effective way of sequestering that carbon and trapping that carbon. Eventually, it percolates up. It diffuses up through the soil. It goes, if it's in an aquifer, it diffuses through the aquifer, and it can come back out into the atmosphere. So not a great idea. And you'll hear talk about, well, why don't we burn clean coal? There are ways to make coal burning cleaner, to reduce the sulfur dioxide and the nitrogen or the nitrogen dioxide, etc. But that's expensive. And industry doesn't want to do that. They don't want to create a higher cost, because then that cost has to get passed on to the consumer. So what we've seen in the U.S., the coal trend in the U.S., coal consumption, coal use has been going down. This, let's revitalize the coal industry. It's not going to happen. It's not realistic. We're running out. The sources are getting smaller and smaller. It's hazardous. It's environmentally pollutant. And people are moving away from it. Industry has just moved away from it because there's cheaper sources of energy. So unfortunately, coal mining is not a viable long-term thing for people, because it's eventually going to be not needed. We may not run out, but at some point people go, well, you know what? We moved away from coal. It's not the source we want to keep using. But what we do see in Asia, especially in China, the desire and the need for coal has gone up. They've kind of leveled off, and we're watching to see if they're going to start dropping down, because they are burning a lot of coal, and it's creating some significant environmental impacts with the amount of coal consumption they're doing in China. So, all right, so coal's our first one to talk about here. Oil. Now, oil forms similar to how coal forms. You get producers. In the case of oil, though, it's marine algae and plankton from inland seas. These organisms die, they drift down to the bottom of the inland sea, they get compressed for millions of years in the environment that lacks oxygen, so then that picks up the sulfur, and that stuff gets compressed and compressed and compressed, and eventually the deposits form into oil. We can also get gas from this, and this tar-like material. We'll talk about these things as we go through the oil information here. So this tar-like stuff called tar shales and tar sands and things like that. So it's not a solid compressed structure. It's more fluid. You know, oil's got viscosity or thickness to it. Gas obviously has less viscosity. Tar stuff, kind of sticky tar. So you're not this hard chunk of coal. So the challenge here is when we're talking about, hey, how do we get it out? Environmental issues of getting it out. You know, we got to drill a hole. Often you're going through the water table. You're drilling that well down there. You're drawing the oil up, or the gas, or whichever one it is. You're drawing it up from the earth. Big potential for environmental pollution. This is a diagram of fracking. So we talked about fracking a little bit in the last unit. So you go in, you drill your well, you create these cracks or fissures, and the idea is to get the gas to flow out into your well pipe, get the oil, the fuel, whatever source you're going after, to get that to flow into that pipe. draw it up out of the earth and get it up to a point where you can tap into it and access it. So again, some environmental issues there. Tar sands and oil shale. Tar sands, imagine taking oil and mixing it in sand or shale. Shale is just thin rock. So you mix it in shale, and they call it bitumen. That's the name of the actual substance that's being pulled out. And it's got this viscous mixture of hydrocarbons. So poor example, but imagine taking a bottle of oil, pouring it in a bowl of sand and mixing it together. All right, great, we got it. But now you got to separate the sand from the oil. And usually you use heated water to do that. It can produce greenhouse gases to separate that stuff out. It creates this nasty sludge. That's usually got a lot of toxins. Again, don't forget about the sulfur. Just not a good way to clean and separate it out. But people go, wow, it's a new source of oil. It's a new source of fuel, these tar sands. So we got these massive tar sands up in Canada that are being tapped for it. But there's a bigger cost to it. So cost changes compared to conventional oil. Oil shale. Imagine thin, flat rock, what we call shale, with oil soaked into it. So sedimentary rock with this stuff called Carrigan. So bitumen is associated with tar sands. Carrigan is associated with oil shale. And again, to get the oil or the fuel thing away from the rock, you got to heat it. So you heat it up, you use pressure, you use steam, you use hot water, and you separate the oil out. The oil rises, you tap that, harvest that, or extract that oil. But now you got all this superheated water with this shale and pollutants. Well, now you just polluted your water. And some of this is being done in environments where water's not readily available. So you're tapping aquifers or using rivers to mine these tar sands and this oil shale, and it presents a significant environmental impact when we go after it in this form, in this fashion. So the other source that's being tapped, or I should say possibly being tapped, is the Arctic Ocean. Now, sea ice is melting. It's been melting, but the sea ice cover is not staying as long, and it's not, when it freezes up every year, it's not freezing as large. So we're we are witnessing a greater amount of water exposed in the Arctic Ocean. Scientists, geologists, oil industry folks, etc., are looking at that saying, there's possible oil and natural gas under that ocean. Can we now get up there and get to it because the sea ice is not as thick and it doesn't persist as long? So check out the picture of the map here. So look at the ice pack, the white there. Compare over here. You have significantly more area of the Arctic Ocean, this area here that is now open, this area here, compared to it back in the 80s. So every country, not every, lots of countries are trying to stake claim to some of this territory. You got the US, Canada, Russia, Denmark, Norway, basically all the countries that surround the Arctic are claiming territories. And they're all looking at going, can we tap that for oil and for gas? It's estimated 15% of the undiscovered oil on the earth will be in that Arctic Ocean, and about 30% in natural gas. So this is a consequence of climate change that is possibly opening up the Arctic Ocean for gas and oil discovery. Some people would hail that as a great thing. Yay, we can now get in there and get more oil and gas. Others are looking as, now they go in the Arctic, what kind of environmental consequences are we going to produce trying to go after those resources in that environment? All right, so in the next lecture, we're going to take a look at some of the problems associated with oil, shale, tar sands, etc., when we're using that as our energy source.